such a full room after lunch. You guys are amazing. Okay, so my name is Rouan. That's me in Cape Town. I'm from South Africa. That's why it's so sunny there. But I'm very excited to be here in Oslo with you today and talk about secure code review. And I guess let me get to know you a little bit first. So, like, just show of hands, who here is from Norway? Okay, so the vast majority. Where are other people from? That's just next door. Ah, there we go. Now we're talking. Okay, one more. Belgium. Very nice. Okay. So I'm here to ask the question today. Oh. Give me a second to make sure that doesn't happen again. There we go. We're here to ask the question, is this okay? When we're busy looking at code. And so I'm going to break today into two halves. That should pop up again at some point. I'm going to break this into two halves. The first half, what I'm going to do is I'm going to talk through a few basic tips for reviewing code. And we'll talk a little bit about what reviewing code is and what's important about it. And we'll just I'll try and share my experience. I'm by no means a security expert, but I'm here to share what I've learned over the last few years. And then in the second half, we'll look at an example pull request together and we'll try and review it and we'll see what security issues we can spot. So yeah, that's me. I'm Rouan. I am an engineering lead at a company called Haven. We do holidays in the UK. If you ever want somewhere sunny. No? Okay, so I guess the first question to answer is, why am I interested in security? And so back in 2018, I was doing Node.js development for a company that was looking after data for teachers and schools. And a lot of this started happening. So I don't know how many people here are kind of in the JavaScript space in some way or another. Okay, about half the room. All right. So 2018 was a busy year for Node and NPM. And there was a library called ESLint, which most JavaScript projects use, that was compromised, and people were stealing NPM credentials. And if you stole the NPM credential of someone who had a different package published to NPM, it meant that you could impersonate them and upload your own malicious code. That wasn't great. There was also a package called something like Flatstream or Flatmap. No one knew what it did, but it was used by a package which was very popular. And so there was a vulnerability where people were stealing Bitcoin off people's computers simply because they were engineers who had downloaded a package which happened to download another package onto their laptop. So this was kind of happening in the JavaScript space at the time. There was something called the Node Security Project, which people started paying attention to. It was all about finding known vulnerabilities in your supply chains. Like, what dependencies do your dependencies have that might be introducing issues into your code? NPM purchased the company called Lyft, which made the Node Security Project, and then built all that auditing into NPM. I then created an open source library called Npm Audit Helper, because when I switched from using NSP, which was the Node Security Project tool, to NPM Audit, I was overwhelmed by the number of vulnerabilities that I was presented with. There were just hundreds, and in some cases thousands, and I had to have some way for me and my team to work through that. So I built a little tool to help with that. And then, everyone here know what GDPR is? Yeah, okay. 2018, the year of GDPR. Executives running around going, why aren't we secure? And developers going, how can we be secure? And it was called a bit of a mess. And like I said, we were looking after some important data, and so it became important to me that we were looking at, the word is accountability, that we would take responsibility and be accountable to saying, we're looking after important data for people, and we're doing as good a job of it as we can. All right, so let's go through. Oh, hang on. I've got a disclaimer slide first. So I'm here to talk about secure code review, but it's important not to put too much pressure on yourself. Because saying that code review is the point in the process at which all security issues must get caught, that's too much pressure. There's no ways that's going to happen. Things are definitely going to slip through. And we're going to do our best, and we'll talk about that today. But I think it's important to recognize that it's too much pressure to say that we're going to catch everything in code review. Other things that are important are to build awareness, get a real security culture going. Some other speakers have been talking about that today. Threat modeling is a great tool for understanding what it is that you actually have that other people might want to take from you. Penetration testing, of course, and static analysis, which can even be built into the code review process. There are some great tools for that. Here we go. Number one, feel free to stop me at any time for questions, or if I'm talking too fast or anything. Where is the input going? So the number one trick that we have hackers using is to put some malicious input into our system somehow. And when you're reviewing some code, and code review could mean a number of different things. It could be you reviewing a pull request that someone on your team has opened. It could be you reviewing your own code before you offer to merge it into your team. It could be you reviewing the code of the person sitting right next to you because they've asked you to look at something. Or it could be a pair of people working on some code together and trying to decide whether it's secure or not. So the first question to ask is there any new input? Is there anything that we need to be suspicious about? Have we changed the way that the input is handled in any way? Are we doing something with that input that we didn't used to do? We should ask ourselves where it's stored. Is it going into a database? What kind of database? If it was going in the database and now it's going into the logs and the database, what should we be thinking about in that particular case? And then lastly, how it's used later. Lots of injection attacks are less about getting the insecure code into your system and more about how that might be used later to exploit it in, for example, a cross-site scripting attack. So I did a secure coding course with Stanford a couple of years ago, and I learned a lot of things that I didn't know, and I learned a lot of things that I'm not sure I'll ever need. It was a good mix, I think, of like some fairly technical things and some things that really resonated with me. The main thing that I wanted you to take away from this slide is the idea that in this basic example here, you've got a memory stack, and an attacker is going to inject some sort of instruction in there that is going to trick the processor into thinking that some data is actually an instruction because the data has overflowed into the instruction portion of the code memory. And this is a very common approach. It's how we get cross-site scripting. It's exactly the same kind of attack. You're putting some malicious JavaScript into someone's database. They're going to put on the screen later. Number two, are the right AAA checks in place? So the AAAs here are authentication. Have we checked that the person is who they say they are? And more than that, have we checked that they still are who they say they are after they've logged in? So we need some sort of token of identifying whether someone has securely logged into your system. Secondly, have we checked the right things for authorization? So authorization is, are they allowed to do what they're here to do? So that might be a really basic example is maybe you have some admin functionality on your website, but an ordinary user shouldn't be allowed to do that. So when we're reviewing code, it's important to check, have we, for this particular piece of functionality, ensured that only the right people can take the actions that they need to? And lastly, auditing. And this is the one that's often forgotten. And this is all about making sure that we know that something has happened if it is noteworthy. So it's all kind of about taking notes of important things. Has someone changed their password? When did they do that? What country were they in when they did that? How many times have they done that recently? And the important thing to learn with this is to apply the principle of least privilege. So when you're looking at a piece of code that you're reviewing, think about, have we implemented the principle of least privilege, which basically means, have we made sure that only the people or only the system actors that absolutely have to are allowed to take the action that we're looking at in the code? Thirdly, have the assets changed? So the first kind of thing with GDPR is that we have to ask ourselves, do we have the consent and the legitimate interest to process a piece of data? So what that essentially means is that if someone is trusting us with their data, they need to have said, yes, you may have this data. And secondly, we need to have a real legal reason to process that data. So if, for example, we're running an online dating site, we have a legitimate interest to have that person's first name, surname, email address, and a photograph of them. But we might not have a legitimate interest to have any medical information about them. And what's interesting about GDPR is it's all about the nature of the assets, and we need to think about whether we're storing those, are we storing any special information? And I'll show you some definitions of special information in a second, but the three kind of broad examples in GDPR are personally identifiable information, so that's information that I can use to figure out who you are, whether that's your name or not, so like your address, or maybe a few places where you've worked. Special category data, so this is data like your ethnic origin, religious or political beliefs, whether you're part of a trade union, pieces of information like that might be sensitive, and lastly, criminal offense data as well. And so when you're looking at a piece of code, it's not only about looking to see, okay, we have a set of practices in place for making sure that we look after data. Now a new piece of information comes into our system. let's say previously we didn't process any health information, but now we do. That's protected under GDPR. And suddenly the whole way that we look after data needs to change in respect of it. We can no longer just put it in our database. We need to put it into an encrypted database, as a simple example. And so when you're reviewing a pull request, it's not only about the code directly in front of you. It's about knowing what other parts of the system are in play and whether they offer the kinds of protections that the data needs if the asset of kind of class of the data has changed. So here are some examples. I mentioned some of these already. Genetic data, biometric data, health, sex life, and sexual orientation are some of the ones that I didn't. All right, number 4, are we leaking any data? And so this is quite a common exploit. If you have an API that offers information about your system, is your API providing more information that your client needs? So let's say you have a web application, you make an API request to get some information, let's say for our online dating example, and you get back a bunch of information that you don't really need for a page where you're just listing profiles. So you're listing profiles, you've got someone's first name, you've got their surname, and you've got a URL to a picture of them. But maybe you're also pulling down their address or their email address, even when that's not strictly necessary. And it becomes very easy to scrape that web page and get a bunch of information about your users. Are you logging stuff you shouldn't? This is something that I've seen people run into. I have seen more than once user cookies being logged in the logs, which would make it trivial for anyone who works at a company to go and pull out a user cookie and impersonate a user. And so think very carefully about what you put in the logs. You shouldn't be putting any special category data in your logs, because maybe you have a super secure MongoDB instance where you're putting people's genetic information and their email address, but then you're just putting it in plain text in the log somewhere at the same time. So it's worth thinking about. And the golden rule here is don't keep anything that you don't need, because honestly, data is a liability. Really simple code example in that dating profile one we spoke about. If we're fetching a profile out of the database and we're returning it, don't just return the whole profile. Grab the 2 pieces of information that you're interested in out of that and return it to your client. Number 5, are there any new dependencies? So as you might have been able to tell by my open source interests earlier, this is something that interests me. Supply chain attacks are a big thing at the moment. A lot of people are talking about it. A supply chain attack in the context of information security, what we're talking about is someone injecting some code or behavior into your system from somewhere further down the line. So it's not in the application that you're working in, but it's code or behavior that you're inheriting because of your dependencies. And when you're busy looking at a pull request and someone is adding new dependencies to your system, you should have a look and say, is the library or dependency that's being introduced trusted? Is it popular? Is it well maintained? And very importantly, do we actually need it? Maybe all it does is offers 4 lines of code and we could use our own code to do that instead of pulling in a third-party dependency. This is a snippet from a very small pull request I opened a few years ago. I think this was in NodeMox HTTP. It's a testing library for Node applications. It provides mock request and response objects. And all I did was I was doing something else in the library, and I noticed that it imported a package called net. Now, Node.js has a native library called net. And so when you want to use things like the request and response object in Node, all you have to do is you say import net, and it gets it from the core Node.js runtime. But this package was importing it as if it was an external dependency when it didn't need to. And so it meant that if anyone was squatting on this .net, on this net package name, or if anyone who had a legitimate package called net was perhaps compromised, our whole system would be compromised completely unnecessarily. There's a great tool called Sneak Advisor. I recommend checking it out. You can type any package name in here and it will tell you kind of a general health score. So you'll know whether there are any known security issues, how popular it is, whether or not it's active, just a few indicators. It's kind of helpful little bits of statistics or metrics to help you make a decision. Right, has the configuration changed? Someone was chatting about this earlier today. Misconfiguration is a super common cause for security issues. So here's a news article about Microsoft. They exposed 250 million customer service records due to some misconfiguration. And they had a database and it was accessible when it shouldn't have been. And a really key thing here is that if your configuration isn't code, it can't be part of your code review process. So if all of your configuration to your service is done clickety-click through UIs, it means that it's impossible to review those changes. And so this seems like kind of an obvious thing, but in order to do secure code review, you have to make sure that the stuff you're reviewing is code. Super common one. There were loads of these in the news a few years ago. This is the settings for an AWS S3 bucket. And there's a little button there where you have to say block all public access. And so many of them weren't. And so loads and loads of customer data was exposed on the internet. And I'm sure there's lots more up for grabs as well out there on the internet. Because what's the kind of thing that you use S3 for? Big, cheap place to put stuff on the internet is backups. Right. Oh, where are we going to put so we've got this really super secure database. Where are we going to put this backup? Oh, we'll stick it in S3. But what do we do if the S3 bucket isn't encrypted and is open to the public? Number 7, is anything being cached? And this is something that I've run into a surprising number of times. One thing that you definitely do not want to do when you're running a website is inadvertently expose information to the wrong people. Now, the wrong people in the security mindset are often kind of malicious attackers, someone trying to get to some data that they shouldn't have access to. But it's also not great if we're showing information to people who weren't specifically looking for it, but now have got it. And so the classic example here is a user. Let's take our online dating profile example again. So let's say, for example, I want to see my history on the online dating profile. So I open up the app and I want to see what dates I've been on and how I've rated those. And when I log in, I see dates with completely different people. And I'm actually busy looking at someone else's profile. And when I scroll through the information, I can see, oh, well, this is who they've dated and this is what they look like. And you can imagine, that's kind of a personal reputation risk, I guess, but you can imagine financial scenarios that are similar. And this often happens due to caching issues. So in the modern web, it's super important that we cache information because people want information quickly. But we need to be careful that we're caching that information in the correct way. So if your data is caching things that it shouldn't, for example, a person's very specific dating profile, that's bad because we're going to be returning that to someone else. So you should understand when you're reviewing code what the default caching behavior is for your application. Very often the default caching behavior is performance oriented. So systems cache things aggressively. And so when you're busy working with data, you need to think very carefully about how you interact with that. My personal recommendation would be to rather have a slow website than an insecure website from the performance of cache optimization. So rather have your default caching behaviors be conservative and then do something to make sure that, because you can look at a pull request and say, oh, well, hang on, we should just add some rules here so that this page is cached, so that we have better performance. And if you miss that, it's okay. But if you're in a scenario where the thing that you miss means that you're leaking information, then that's not great. Number 8, have you checked the borders? So how many people here use kind of like a pull request model of reviewing each other's code? Okay, all right, most of the room. Just keep your hands up for me for a second. How many people feel like they have enough time to review all the pull requests? Ooh, okay, all right. So this is a core problem. I wrote an article about this recently because I find this stuff particularly interesting. I think we have too many pull requests, and I think we expect too many reviews, and I think we're generally just going really slowly. But today is not that talk. Today's talk is about secure code review. And one of the things that I think you can appreciate is that sometimes you're pressed for time. And I think security is one of the things that falls by the wayside because, on to the next thing. But a helpful trick that I found when I don't have a lot of time to review a pull request is to check the borders at the very least. So what I mean here is look at the borders of your application. Where are things coming in and where are things going out? If you look at a pull request and you always ask yourself, what information is coming in the functionality that I'm busy reviewing and what information is leaving, then you've got a reasonably good sense of what might be going on. So if, for example, you're busy reviewing like an MVC controller, an MVC application, have a look at the controller that's accepting the user input, have a look at the database where that is being stored, and make sure that both of those interactions are secure. And then at least you're doing some very fundamental security checks. All right, bonus number 9. I could have just called it number 9, but I had 8 in my head, and so when I added number 9, I felt like it was a bonus. So here we go. No, the reason this is a bonus because I think it applies to all 8 of the other kind of principles or tricks that I've spoken through. And that's to make sure that you are always more than one mistake away from a security issue. So I don't know if you've come across the term the pit of success before. No? Okay, so there's a link to an article there. It's great. The basic idea is you can imagine something called the pit of despair, where everything falls into, and it's really terrible. But let's turn that on its head and create a pit of success. And so the idea here is that if anything goes wrong, if we have a mistake, you have a safety net in place. Someone spoke about the golden path earlier. It's similar. You basically want to fall into safety rather than to fall into a hole. And so, like I said earlier, code reviews are not going to catch all of your big issues. You are going to make mistakes. And there's a real key, important software engineering principle, which is that you should make sure that you're always more than one mistake away from disaster. And I think the same goes for security. So if you make a mistake and you miss something, is there something in place? Is there another layer in place to make sure that it's harder to make a mistake? So if, for example, we're talking about a web application, maybe you have an API that can be accessed. And in most cases, your application deals with, or in some cases, your application deals with sensitive information. If we make it the default that we lock that down, unless you've got some sort of token saying that I am allowed to access this information, then we are secure by default. And that is really powerful because if someone forgets to add that token or that mechanism, if we have an endpoint that needs to be publicly accessible, what we need to do if we make a mistake is we just, the page isn't accessible to anybody. And it's very similar to the principle of least privilege that we spoke about earlier. And then because you can imagine the alternative, right? You have a web application where by default everything is open. If you make a mistake, things get through. And so in this case, you're making sure that you're always just kind of having a little bit of a safety net there. All right, so just to talk about me personally a little bit again, like I said, my interest in security has developed over the last 5 years or so, and these are a few tips and tricks that have helped me learn. Maybe they'll be helpful to you as well. So the first step for me was to find a security mentor. Now, a security mentor, what I mean by this is basically just someone who knows more about security than you do. It doesn't even really matter how much more they know than you, but find someone who knows more about it than you do and try and spend some time with them, try and learn from them. If you don't know anyone at your company or in your professional network, there might even just be someone that you can follow on social media that you can learn from. I find that to be very helpful. The second thing is, how many people have post-mortems at their company? Does that word resonate here? Like it's like we have a look at an issue and we see what went wrong. Yeah, okay, some nods here. Go to those, whether you're invited or not, turn up and say, oh, okay, there's a post-mortem for a security incident. I'm really interested. I'm here to learn about it. And maybe you work somewhere super classified and they won't let you. But I think in most cases, people who take an interest in security, as I'm sure you well know, are outnumbered. And so when people recognize allies, they're normally quite welcoming and say, that stereotype of the tinfoil hat on the security person, I don't think is really true. I feel like normally people who care about security welcome other people who care about security. So turn up and have a look. I listened to a podcast for a while called Smashing Security. It's not really an InfoSec podcast. It's kind of like a general security podcast, and it's a really basically, if you want to hear all the way that people's smart homes get hacked and all the hilarious things that happen because of it, give it a listen, and it just kind of helps you with that security mindset. Most organizations probably do regular penetration testing. They normally get like a third-party consultancy in to come and help them. Offer to help during those. Be the person who says, okay, yeah, I'll go ask all the team leads which endpoints need to be tested, and I'll go and make sure that I hand the report out to who needs to have the report. And even though it can be like not the most interesting work, it means that you'll be right there. You'll be looking at the report. You'll be seeing what people are finding. And that can be really interesting and help me learn a lot. And lastly, try and find a good security course online. I'll be the first person to admit that I don't know a huge amount about security. And I think in our industry as a whole, we don't really know all that much. And so when there is good content, go and find it and enjoy it. Okay, so a quick recap, and then we'll get to our little practical session. So number one, make sure that you pay attention to the inputs into your application. 2, make sure that your AAA checks are there. So that's authentication, authorization, and auditing. 3rd, pay attention to the types of assets. In the pull request that you are busy reviewing or in the code that you're busy having a look at, has the nature of the data changed? And what are our implications? What is our responsibility regarding that change? Number 4, are we leaking any data? Or do we have any data that we don't really need? Number 5, have a look at the dependencies that we're getting in. Do we need them? Are they safe? Are they okay? Are they vulnerable? Number 6, configuration. Number 1 way that we have these big breaches is misconfiguration. So make sure that your infrastructure is code so that you can review it and make sure that your configuration is okay. Number 7, make sure that you understand the default caching behavior in your system and that you are not caching anything that you shouldn't. And finally, number 8, make sure that whenever you're looking at code that you're checking the boundaries. Okay, right, so give me a second to get set up and we'll have a look at a pull request together. Okay, so can we see some code? Is it big enough? How's that? Good. Okay, you're a quiet bunch. All right. Okay, so I've got my online dating application here. I've spoken about this a little bit already. So this is super simplified. Basically, all this application does is it allows you to create and read dating profiles. So a dating profile would be me saying, "Hi, I'm Rouan. I'm married. I'm not interested in dating. I shouldn't be on this website." More hypothetically, "Hi, my name is Sue. I'm looking for, let me not do examples." Okay, all right. Okay, so here's a test. I hope that no one minds the JavaScript. It creates a profile. So in this test here, we're making a request to our application. It's a post request. So we're saying that at the profile called Ada, we've got a cookie set, and we're sending a payload with the first name of Ada, and then we're getting a response back that has been created. In a real test, you might also go and look in the database to see if it's there, but let's go with this for now. It only creates a profile once you're already logged in, so you need to have a user before you can have a profile. Just have that distinction in your mind. So if I send the first name but I don't have a cookie, I get a 401 back. It doesn't create an invalid profile, so if I send a last name without a first name, I get a 400 error back. I can get a profile so long as I have a cookie. If I don't have a cookie, I get a 401 back. So this is the basic shape of the API. Let me show you a few more files. The database file is just a complete dummy. It doesn't do anything. The index file here is just a plain Express application, so it's a very basic web application. Nothing particularly interesting there. I've got some middleware here. 2 pieces of middleware that I've got. The one is to check that you're logged in. All it does is to see if you have a cookie with a valid user on it. We say that's fine. Otherwise, we return the 401. We check that the user matches the request. That's to make sure that the user that we're busy interacting about, or trying to update, actually matches the user in the cookie. And then we return a 403. No major dependencies, a few there, just mainly Express related. And there's a validation library called Joy. And then this is kind of the main bit here. Let me just turn the wrapping on. So we can get a profile. What that does is it grabs the username from the parameters from the request. It goes and fetches the profile from the database with the username, and then it returns that in the response. And then we've got a create profile function over here that goes and takes in a profile from the body of the request. It passes it to the database, and it returns a 201. Okay, so that's basically it. Here is some a root file. We're exposing 2 routes, a get route and a post route. So the get is to get a profile, and the post is to post the profile. You know that already. And then we can see here, let me wrap this file as well. You can see here that when we're getting a profile, we're checking if someone's logged in, and then we're getting the profile itself. And then if someone is making a post, we check that they're logged in, that the user matches the request, that the profile is valid, and then we go and create the profile. All right, okay. Now you can all build online dating applications. Congratulations. I'm sure you're glad you came to this talk. All right, so now I've got a pull request for us to review. Okay, so got a pull request here. It says add an endpoint for updating profiles. And it says this pull request adds an endpoint that updates a user's dating profile. I've also introduced a few new fields that our users really want on their profiles. Okay, so it says one thing, but there are really 2 changes in here. Let's have a quick look at the changes. Okay, so someone's come and changed the profile.js file. They've added a new function called update profile. It takes in the parameters and the profile itself. It goes and grabs the username from the parameters. It then makes sure that it updates that profile in the database and then returns the updated profile. In our routes file, you can see we're pulling in that updated profile. Here are those new fields that have been added: ideal date, sexual orientation, favorite color, favorite food. And then we're asserting that the schema, that the data is valid according to our schema. There's a new endpoint here for the put. Check that they're logged in, all that kind of stuff. And then here is the test file. So they've actually added some tests as well. Who has reviewed a pull request with tests recently? I'm not looking. It only lets you update your profile if you're logged in. So you get a 401 if you don't. And it updates the profile with extra information. So if you give all the stuff, then you get that. And you can check that all the stuff is there in the response. Okay, so this is our pull requests. So I've prepared some comments here on some issues, but I would like this to be interactive. So what have we spotted? Does anyone want to go first? Like any security issues here? Yes.
You can update other users' profiles.
You can update other users' profiles. Fantastic. So can you just tell me more or less in the code what you're talking about?
In the route, I think you're missing the middleware for checking that it's your profile.
Over here on line 26?
Yeah.
Amazing.
For the online viewers, what the audience is saying.
Oh, I'm sorry. Yes, of course. Sorry, what's your name?
Alexei.
Alexei? Okay, well, what Alexei is saying here is that on line 26, what we've got is the check for whether the user matches the request, which we have on line 27 on the other route, is absent. Absolutely.
So we can see other optics.
Sorry? Oh, you sorry. There we go. Is that better? There we go. That's what we're talking about. Yes. And so what he's saying is that a user is actually able to update a different user's profile because we're not checking that the user who's taking the action is the user who owns the profile. Brilliant. Okay, so this is a code review session. So let's do some code reviewing. So I'm actually going to go grab some text I prepared earlier. And let's add that on here and we can read it together. So let's start a review there. So I'm saying here that this endpoint is doing an authentication check, which is great. I notice that it's not doing an authorization check though. At the moment, a user would be able to use this endpoint to update any other user's profile because we're not checking whether the logged in user is allowed to update the profile in question. Excellent. What else have we spotted? Yes.
I think you get back a lot of information that is not necessarily related to updating a profile.
Okay, so you might get back a lot of information that's not necessarily related to updating a profile. Do you want to point me in the right direction here?
Yeah, I think I saw it at least in the test.
Yeah. Okay. Brilliant. So I think the code for that. Oh, sorry. This is the bit that you're talking about.
Yes.
Okay. Excellent. And if we go and have a look at, oh, I see. So this is an interesting thing. Do you notice that in this pull request, that test was the only clue to the fact that this might be happening? And so this is kind of an interesting thing because this is not something that people talk about a lot or think about a lot when they think about code review. When someone mentions code review, the kind of immediate reaction is I'm looking at some code and I'm reviewing the code that's changed. But what we're actually asking when we're asking for a code review is we're asking, does this change to the system make sense? And that system may include more than just the code that you're looking at the time. So let me flip back to the code editor here. And if we have a look at this profile file, what you'll see is that when we create a profile, if we call the create function, what we're doing is, oh, sorry, it's not create. Sorry, it's in the, oh no, the code is right here. Ignore my speech, but it will be relevant later. Okay, so when we do a database update, what we're doing is we're getting an updated profile back from the database, and then we're returning that to the client over here. So if, for example, you had, oh, let's write a comment. We could be returning more information here than required. For example, I'm typing in front of people. For example, if the database contained an internal popularity score, yikes, we would return that to the client instead of just the information requested. Cool. And in this case, it's an update function. You've validated that the person who's updating it, or hopefully you validated that the person who's updated it is the person who said who they say they are. So it's probably okay, but there's no real need to. And so I feel like allow listing properties is a good practice to have in general. What else? The back there?
Well, it's a temporary getter, which is actually the public profile that you're returning everything in the profile that no one includes the sexual orientation.
That's correct. And you can cut my speech from earlier and paste it into this point of the talk, because what the gentleman has just observed is that the get endpoint is vulnerable to exactly the same thing. And that's the endpoint that we can't actually see in this pull request here. So if we just have a quick look here, we can see that the get goes and fetches the whole profile and then just returns it. The system here only has one get, so we can assume that that get is being used in multiple places. So let's say, for example, we have an online dating profile application where you're only allowed to see someone's full dating profile when they've said you can. And otherwise, all you see is a minimal profile. What if we're showing people a list of those minimal profiles? We're calling this get function there, and we're actually exposing more information that you wanted. So in that case, we might even want to have a plan to fix that as well. Thanks. Okay, what else have we spotted? Yes. A mass assignment vulnerability. That's excellent. So what we're talking about over here is line 15. So what you're saying is that someone can come and update multiple fields, even though those might not be all of the fields that are available in the form. I think that's a really good, well spotted. This code is vulnerable to a mass assignment attack. Users, what might be on the profile that we don't want? Could update their popularity score even though that's not available on the web form. Excellent. What else? Yes.
It's not part of the pull request, but the cookie equals Ada can easily be changed to Bob.
Oh, the cookie. I must be honest, the cookie stuff is definitely not secure in this. It's for demonstrative purposes only. Yeah, that's not a secure cookie. But yeah, well spotted. What else? What else have folks spotted?
The dependency to the third-party package Joy.
Joy, the dependency to the third-party package Joy. So let's have a look at that. So the package.json file hasn't changed in this pull request, but what we're doing is we're using Joy here to do our dependency validation. We can have a look. Let's have a look at Sneak Advisor. Will the internet work? Yep, there we go. Let's search for Joy. Seems okay. It's worth asking yourself whether you do need it or not. You know, you're going to have to use some third-party code because obviously you can write your own validation logic. And for this example, I think that will probably work quite well. But if you had lots of things to validate, for example, trying to come up with a reasonable regular expression to validate emails is a real headache. So if someone else can do that for you, that's good. And this is an excellent, thank you for pointing that out, because this is a good way for us to come and check to see whether that's okay. What else? Yes. Very good. So what we're saying is for GDPR compliance, because we're adding sexual orientation as a field here, there might be like a form that we need, a consent form that we need users to accept that it's okay for us to have this data. or other things. So let me copy my comment about that because it's a long one. Oh, don't look too closely, you'll see more. Got to scroll fast. Okay. Sexual orientation is defined by European law as special category data. Great thing to do when you're reviewing pull requests, add some links in there. So we need to have a good reason to store it, and we'll need to be extra careful with our data in future if we do decide to store it. So let's get the whole team together so we can discuss whether we really need this information from the user, and if we do, what we can do to ensure that we take really good care of it. So that's very good. On that application that I was working on in 2018, we were looking after lots of special category data. We had we had criminal offense data as well. We had personally identifiable information. We knew whether teachers were barred from working with children or not. And so it was really important to us to make sure that we were looking after those things. And that's when I learned all about this GDPR stuff. What else have folks spotted? Yes, sir.
It might not be really security related, but your sexual orientation there. I can provide any string I want.
Right, okay, you could provide any string you wanted for the sexual orientation here. Yeah, you're right. I don't think that's particularly security related. I think the validation in general, it's just kind of like super basic. But is it not security related? Maybe like what kind of stuff could we put in there that might be really bad? There we go. Yeah, exactly. So XSS is what the gentleman here is saying, and absolutely. So let me go and copy my other long comment. Alrighty. I noticed that our validation doesn't check the input for the malicious code. And this is not just the sexual orientation field, it's all of the fields that we have there. If the request had a payload like this example here, where we're setting, I used the ideal date one for this example, setting a link to some sort of terrible JavaScript script. The put endpoint could then be used to introduce a stored cross-site scripting attack. There's a link there to explain what a stored cross-site scripting attack is. Remember when you're reviewing code, it's really helpful. You know, we spoke earlier about how code review can't be the last thing, like the last line of defense. Like, there should be lots of other things on the go as well. And one of those things was security awareness. And I find that code reviews can be a really helpful way of building awareness around not just security issues, but any issues. And so, you know, take the time to review code and to share knowledge while you're doing that. We would include the malicious code on the profile page when we display the user's profile to other users. Depending on their database implementation, we may also be vulnerable to a SQL injection attack. Quick coding joke. No chance of that. This issue is also present for the existing post endpoint on line 27, so you should remember to fix that too. And this is also a helpful thing, right? Like, this is an existing vulnerability that we've noticed because we're now scrutinizing the code again. And this is another helpful thing about code review. You're often going to catch issues that aren't part of the change that you're looking at, but the change that you're looking at is making you look at that code base in a different way. And so that's really helpful and really important. Okay, what else? Yes.
On that last point about XSS SQL injection, is that something you try and address there on the get or put request, or is it more like you'd follow that input through and think, okay, is that going somewhere where it might be misused?
That's a really good question. So the question here is, when we're talking about this cross-site scripting vulnerability here, we're getting this data in, and we're doing some sort of, I'm making a comment here saying that we should validate that to make sure that we don't end up with a cross-site scripting attack. And the question is, do we do it at this point? Or do we think through it and think about where does this data end up and do it at that point? And so this is a really interesting debate, and I've had this debate many times, and I think it falls to different sides depending on what's going on. Because the question is, do you validate your input on the way into the system, or do you validate your input on the way out of the system? And my contention would be that you should always validate your data on the way out of the system, because that's when you're busy putting it kind of in harm's way, right? So like if you are putting data, if you're running, so if your application has a database layer, or if you have a separate application that handles the storage into a database, you want to make sure that that layer is doing a check to make sure that we're not having a SQL injection issue, for example. If you have a web layer where we're displaying stuff on a web page, we want to make sure that that's not vulnerable to a cross-site scripting attack. So those are kind of have to be defaults that are baked in. And it's kind of like that pits of success. Use a framework where it's difficult to perform a cross-site scripting attack. Or use a framework where it's difficult to have a SQL injection attack. But I think that with certain kinds of data, and you have to use your imagination a little bit. You have to think, is this something that we're likely to use on a web page? Because maybe at the moment you don't, and so you can consider inputting. There's also a question of scale, though, like how much data is there? How much time are we going to spend validating all this data? There's no clear answer to that question. Yeah.
Yeah, I mean, just as a follow-up, as Christian gave the example of sexual orientation, that might be a type of field, but actually we do know exactly what we're going to receive there. We know that we're going to receive this list, and maybe that's a good point of validation, seeing if it's just going to be these items. So we can say, okay, this is an allow list of these are the items we expect for this field, and we're only going to accept that, like a date. We know we're only going to accept the date format. So for each field, if we've got an opportunity to say that we can cut down a lot what we're actually receiving here, then that's ideal. We don't have to start imagining what's going to happen later on, because we need to do the checking later on as well. But on input, we've got a small list of things we know.
Yes, so that's a really good point. The point here is that when we're accepting input, it can be really helpful to restrict the input that you're happy to accept. So only accept the input that you're happy to accept and look after. So a really simple example is if you let someone input a color, don't let them give you any hex value. Let them give you white, blue, or red only. Or more realistically, make sure the shape of the data looks like a real hex value. Yes?
Your dating site only accepts people that are older than 23 years old?
Your dating site only accepts people that are older than 23 years.
Because it's only limited to the year 2000. If you're born after that date, it's not allowed.
Yeah, sorry for you. This is my very special over 23s dating site.
But also related to that, if you save data for minors, then you might have to comply with other regulations as well.
Yes, I think that's probably true. Yes. So the point here is that if you are storing data for minors, you'd have to think about that data differently as well and treat that data differently. And I think the age probably varies by region and jurisdiction. Yes, sorry, there are two hands. I just want to hear from, yes.
What about default values and backwards compatibility of the sexual orientation and your dating stuff? So you restrict the different types of inputs that you allow, and there's already users in there, you might get the wrong field value.
Right, okay, so let me make sure that I understand what you're saying. You're saying that if we take the sexual orientation field as an example, if we have some predefined list of values or a set of default values, if we introduce that at this point, we might run into issues where we've got some data that's not valid.
No, I was thinking about, you might say that the user is special because that's the default value, they're not. That was an issue.
I imagine ethically or politically, yes. I'm not sure about the code. Maybe come and chat to me afterwards and we can figure it out. Yes.
Yeah, since we know accept view data that are more sensitive, we would also need to integrate logging of this application, which might be also in a completely different application. It might be in an ingress or something like that.
Right.
So, not something that may be shown in code. Yeah, in this review, look at it still need a review.
Yes, so the point here is that we would also need to think about the logging that this application is doing because we're introducing a new field that we might need to treat differently. And that logging might not even be in this application at all. It might be part of your cloud infrastructure or something like that. So let's say quite a possible example is you've written some code that says that if I get a post to this URL and I fails for whatever reason on the server, I'm going to log the request so that I can inspect it and have a look and see why it went wrong. And maybe that was okay when we weren't capturing personally identifiable information or special category data, but now it's not. Okay, you've done really well. You've found most of the security issues that I had in mind and a couple extra as well. So what I would like to do is to give you the chance to ask any other questions as well. If you keep spotting things, that's fine. But if you've got any other kind of general questions about code review or secure code review or anything else like that. Yes.
How do you deal with your dependencies? Because, well, you have direct dependencies, but you also have inherited dependencies. Do you basically look, in this case, like your package.json file, for example, and see what things you have in there and audit them in CI? Or do you look them all up? Or how do you reckon it?
Yeah, so that's a really good question. So the question here is, when you're busy looking at a dependency and you're trying to evaluate that, are you looking at that dependency? How are you looking at the dependency? When you're looking at the dependency, how are you figuring out its dependencies and like, you know, how deep the chain goes and like what you need to be having a look at? This is a tough one. So I'll use the JavaScript example here. A few different things. So first of all, what you want to do is you want to have some sort of automated tooling in place. So there are quite a few open and proprietary technologies that let you do some sort of scanning of your dependencies for known vulnerabilities. So this is all about saying there's a publicly available list of CVEs or vulnerabilities that say library X is vulnerable to whatever, and then basically it will traverse your dependency tree for you and say, oh, you're depending on library X, which depends on library Y, which depends on library Z, and library Z, we know at that version that you're using has a CVE against it that's of this vulnerability severity. So you should go and have a look at that and decide whether that's okay for you or not. In practice, it's not as simple as just that, because what happens is that with so many libraries on the internet, you're going to have a fairly long list of vulnerabilities. And so then you need to try and figure out which of these am I actually vulnerable to, because you might have a high severity issue that you're not exposed to at all because of the way that you're using the library. But there might be a moderate security issue that you are very exposed to, and you have to try and figure out, it'll all be very context dependent. So that's one thing. The other thing is, you use something like this Sneak Advisor to try and get a sense of how deep do I have to drill? Because I'm not saying that Joy doesn't have an issue or Joy won't have an issue, but it's fairly well looked after. So hopefully other people are asking themselves this question as well. If I'm opening a package and the health score is like, it's less maintained or fewer people use it, then I want to have a look at its package.json file. And actually, probably not just its package.json file. I probably want to have a look at the rest of the code as well. And it's tricky because something like NPM, you can publish code to NPM that even though it's a public registry and your source code is public, they don't necessarily match. So there's nothing saying that the code that you're reviewing on GitHub is actually the code that's published to NPM. So, it's a whole can of worms, really. Yes, right at the back there.
One problem with doing the analysis, if you're using that code, or if your code is vulnerable, of course, not right now maybe, but in 1 month, the developer is start using that part of that library.
Okay, so the point here is that we might review so let's say we do a scan, we see that we're using library X, and it's got a certain vulnerability. We say, we don't care about that vulnerability, we're not using the pink functionality of that library. So we say it's fine, we add it to a list of known dependencies that we're okay to ignore the vulnerability for. But then 2 weeks later, an engineer says, oh, we need this thing, I'm going to use the pink library, and then off we go. And that's really difficult to manage. I think what I would caution against in this particular instance is any sort of organization-wide acceptance of risk at that sort of granular level. Because I think it's very tempting to say, okay, cool, we have 60 engineering teams, like 100 and something different microservices. Let's just say no one cares about the vulnerability in Mocha because we just don't use it like that. And then we quieten down our reports. I think it should be down to every individual team to make that decision, because hopefully there's some continuity within a team and we'll remember about it when we move on. No guarantees, but certainly better than a blanket policy, which would definitely cause those kinds of issues. Did I repeat the question? I don't know. Okay. Any other questions? Brilliant. Okay, well, I'll still be here for the remainder of the conference, and right now up here if you want to chat and ask more questions. But thank you very, very much for joining me.